there, Mr. Sutton here with the IM 3 Honors 3-1 Part 1 homework solutions on Intro to Imaginary Numbers.
On this problem, we need to express this radical expression in simplest form, and if the answer choices didn't make it clear, we need to take an I out at some point. The best time to do that is always in the beginning. So I is the square root of -1, so taking it out makes the inside stuff positive. So this first radical I'm going to rewrite as 2i radical positive 50, and from that we are subtracting 3i radical positive 8. Now that I've taken those i's out, I'm going to simplify these radicals further. 50 can be split up into 25 times 2. 25 is the biggest perfect square, so 25 times 2. And 8 I can split up into 4 times 2. Square root of 25 is 5. So 5 times 2i gives us 10i with a radical 2. And then square root of 4 is 2. So 2 times 3i gives us 6i with a radical 2. So minus 6i radical 2. And at this point, since I've got the same radicals and these i's, it's basically just combining like terms. So I have 10 of these things here, 10 of these I radical 2's, minus 6 of these I radical 2's. That gives me 4 of these I radical 2's, which gives me answer choice C. On this one, we're trying to simplify this expression. So before we do anything else, we need to take care of this negative inside the radical. We'll factor out basically the square root of -1 by taking an I out of the radical. So we can rewrite this as negative I radical 36, positive 36 in there. And now the square root of 36 is 6, so this can be simplified to negative 6i. To simplify this radical, we first have to take out that negative as an I, so we can write negative 4i radical 40. And then we're going to split up 40, just basic radical simplifying sort of stuff. 40 can be split up into 4 and 10. Square root of 4 is 2. 2 times negative 4i is negative 8i, so then we can write negative 8i radical 10. Before we can really simplify this radical, we need to take that negative out as an I. So we have I radical positive 180. And then 180, to simplify that, we have to get the biggest perfect square that goes into that, or at least keep splitting it up into perfect squares until there aren't any. So the biggest perfect square is 36. 36 times 5 gives us 180. And then the square root of 36 is 6, so this is just 6i radical 5. First step on this simplifying problem is to take out that negative as an I. So this is really 5i radical positive 48. And then 48, we can split that up into 16 times 3. Square root of 16 is 4. 4 times 5i is 20i, so this is 20i radical 3. On this one, we have to take care of the negative inside the radical before we do anything else. So we'll take that out as an I, and now we just have radical positive 27 inside there. 27, we can split that up into 9 times 3 inside radicals. Square root of this 9 here is 3, so then this is 3i radical 3. To simplify this radical, we'll first take care of that inside negative by taking out an I. So we have negative 6i radical 63. And then 63, we can split that up into 9 times 7. 9 is the biggest perfect square. Square root of 9 is 3. So we have 3 times negative 6i on the outside. That's negative 18i. And then we have a radical 7 as well. To simplify this radical, we'll start by taking this negative inside outside as an I. So we have a negative I radical positive 20. And then 20 we can split up into 4 times 5. Square root of 4 is 2, so this is negative 2i radical 5. For this one, we're trying to simplify this radical that has a negative inside. So to take care of that negative, first thing, we're going to take an I out of that radical. And now I can write 3i radical 96. And now we have to simplify the 96. The biggest perfect square that goes into 96 is 16. 4 also does, but 16's better because you'll be able to simplify a little bit faster. So I'll split this up into root 16 times root 6. And then the square root of 16 is 4. 4 times 3i is 12i, so then we write 12i radical 6. To simplify this radical, we have to take care of that negative by taking an I out in the beginning. So we have 7I radical positive 128. And then we have to simplify the 128. So there's a few perfect squares that go into this one. The biggest perfect square that goes into 128 is 64. We can write this as radical 64 times radical 2. And then the square root of 64 is 8. 8 times 7i would give us 56i. So we can write 56i radical 2.